Welcome back. We are now in a new chapter. We're looking at chapter 4 for elementary statistics, and then we're going to be getting into probability in general for this whole unit. So lots to come. All right, let's dive in. So the chapter objectives, the main objective for this chapter is to develop a sound understanding of probability values. In this sense, statisticians will reject explanations based on very low probabilities by reason of the rare event rule for inferential statistics. Oh boy. So what's that say? It says, if under a given assumption the probability of a particular observed event is very small, and the observed event occurs significantly less than or significantly more than what we typically expect with that assumption, we conclude that the assumption is probably not correct. And you're probably scratching your head saying, what in the heck is he talking about? Well, let me give you an example. So if the lottery is assumed to be fair, and we know the chances of winning the lottery is pretty small, and it is observed that someone wins it 5 consecutive times, then most likely the lottery is not fair. So again, if we know something's not going to happen very often, and then some singular person wins it 5 times in a row, there's something fishy going on. That can't be right. We know the probability of winning the lottery is slim to none, and Slim just left the building. So that's kind of the idea of what the rare event rule for inferential statistics is implying. So, okay, but we're going to come back to that later on. So let's get into some of the basics of probability. So this section presents 3 approaches to finding the probability of an event. The most important objective of this section is to learn how to interpret probability values. Okay. So some definitions to get us started. An event is any collection of results or outcomes of a procedure. All right. So like flipping a coin, you're going to get outcomes of either heads or tails. So, but the event is flipping the coin that generates those outcomes. A simple event is an outcome or an event that cannot be further broken down into simpler components. Okay. The sample space for a procedure consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. Now, out of these, simple event is pretty important because, again, that's the most simplest form of it. But the sample space is also going to be very important when it comes to creating probabilities. So we got to know how to figure out a sample space. So we're going to see some examples of that as we go. But before we get into that, let's take a look at some examples to try to further break down these definitions a little bit. So let's take a look at a die. So a 6-sided one. It's not stated here, but it is. So if you were to roll one 6-sided die, any outcome would be a simple event because the only outcomes would be 1, 2, 3, 4, 5, 6. And we can't simplify that anymore. That's as simple as it gets. So those are the only possible outcomes. So each is going to be a simple event. So in this procedure, the sample space consists of 6 simple events. All right, not bad. Let's kick it up a notch. Let's roll 2 6-sided dice together, and then we attain the following outcomes, pairs of outcomes or events. So now you can kind of phrase it however you want. If you want this top row of outcomes from one die to be the first die, and then this be the second die, great. So you got a 1 and then another 1. You get a 1 and then a 2, and so on. And you get all these different combinations of outcomes. Now, since each outcome is unique and cannot be broken down further, each outcome is a simple event. So, there's no duplication of the overall pair anywhere else. So, you have the 1 and the 1, the 1 and the 2, and you don't see another 1 and a 2 anywhere else. So each one of those are all unique. And so because of that, we can say the sample space consists of 36 simple events. So 6 times 6. All right. Now, how could we get something that's not simple? Let's take a look at this event. However, the event of, say, rolling a sum of 7 would not be simple because there are 6 different ways to roll a sum of 7 and not just one single way. And I've highlighted them here. So 6 and 1 gives you 7. 5 and 2 gives you 7. So this 5 and 2 is not the same as this 2 and 5. So be careful. So first dies first, second dies second. But in general, though, the entire event of rolling a sum of 7 is not unique. It's not simple. So that's kind of the way to think of it. If you can have multiple ways to get that same outcome, then it's not simple. So here's another example. Would selecting a king from a deck of cards be considered a simple event? Well, is there only one king in the deck? No. So that's the answer. It's no, because you've got 4 different kings in there, so it's not simple. But if I said, what about drawing the king of diamonds? Is drawing the king of diamonds going to be a simple event? In that case it is, because you can't break down the king of diamonds anymore. So that's kind of the idea between events and simple events and sample space. Now, like I said, sample space is probably one of the more important pieces of that. So let's take a look at another example involving sample space. So, in general, knowing the sample space from a procedure is critical for finding probabilities. How could we determine the sample space from flipping 4 coins? Now, you could set up a table or something along those lines, but I like to do the following. It's kind of developing a tree diagram. And the way it works is you have to first look at the outcomes from each event. So it needs flip in this case. So let me first get our coins here. So the first, the second, the third, and the fourth flip. So on the first flip, you're either going to get a heads or a tails. But off of each one of those, you're going to get another heads and tails. And then off of each one of those, you're going to get a heads and tails. And you guessed it, one more time after that. And so it's a little tedious, I know, but how do you get your sample space from this? Well, it's a little bit like a puzzle. You're going to have to go down each branch, and then from each one of these, you can list all the different combinations. So the first one is heads, 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 heads. So that is our first possibility. And then from there, we can just keep going and get all of these listed. So I'm not going to list them all, but I think you can kind of see the pattern of what's going on. So now if I said, well, how many outcomes are in the sample space? All you got to do is count these all up. And if you count these all up, you're going to end up with 16. 16 different outcomes in the sample space. So, or simple events. Because again, these are all going to be unique. None of these are going to repeat in here. So they're all unique. So there are 16 simple events in the sample space. Okay, so now that we have an understanding of how sample spaces can be created, and you can also do different combinations of things. If you wanted to flip a coin and roll a die, you can create the sample space from that. And so there's lots of ways you can create sample spaces, depending on what you're doing for procedures. So, okay, so now let's get into the samples, the probability stuff, but I think we're going to conclude this video right now, and then we'll pick up that probability stuff in the next video. So see you in a minute.